In this video, we're going to be talking about number base, and as a guideline to what we are going to be doing, we need to understand that generally our work is mostly done in base 10, and that is why whenever we're working, we get to 9, when we get to 10, we start all over again, 11, 12, just repeating the second digit, and then when we go to 3-digit numbers, we also start all over again, 101, 102, 103, and so on. So base 10 is the default base that we work in. So whenever you are working with number base, the idea is to just get them back to base 10 or convert them from base 10. And what do you do if you want to convert to base 10? So let's say we have some number, say 213 in base 5. So notice that if it is base 5, all the digits will not be up to 5. The maximum digit you can get to when you're working with any base is the number just before that base. So now that you are working with base 5, the maximum digit you can get to is actually 4. So if you have 213 in base 5 and you want to convert to base 10, all you need to do is to just say you are multiplying each of those digits with the base, and 5 is the base in this case, and then once you take each of the digits, you add them with the multiple of the base that you are multiplying with. So having this, you just need to now take powers of the bases starting from the left hand side. So you have 0 here, 1 and 2, and with this, if you can solve this, then you would have converted the number to base 10, and that's what we're going to do here. Now 2 multiplied by 5 raised to power 2 will be 2 times 25, plus 1 multiplied by 5 raised to power 1. 5 raised to power 1 is 5. Any number raised to the power of 0 is 1. So we have this as 3 multiplied by 1. Okay. So if you want to solve this, 25 times 2 is 50, plus 5 times 1 is 5, plus 3 times 1 is 3. And the addition of the 3 is going to give you 58. And this is in base 10. So you don't need to write base 10. You just leave this and say, since base 10 is the default, you just write it as 58, and we all understand that this is in base 10. Okay, now let's assume that we have 58 as a number and we want to convert back to base 5. Then what to do for such case is that you take that number, in this case 58, and you divide by that base that you want to convert to. Remember that this is 58 in base 10, so you are going to divide this with 5. Okay, and if you are doing that, 5 in 5 is 1, 5 in 8 is also 1, but you have a remainder of 3 because 5 times 1 is 5, 8 minus that 5 is 3, so you say this is plus 3. Okay, 11 over 5, that will be 2, 5 times 2 is 10, that means we have 1 as remainder. Okay, and then 2 over 5, we can take that as not having a whole number, but the remainder will be 2. And for you to get the answer, when you convert 58 in base 10 to base 5, you need to take these particular remainders and take them up. So you have this as, in this particular case, you are going to say, that means 58, which is in base 10, is, let's take this up, 2, okay, 1 and 3, but what? In the base 5 that you used to divide originally. So you can see that what we have in here is that this is 213 in base 5, and that is also 213 in base 5. We got 58, and then we got 58 here, and then of course we got 58 here. So this is the general understanding that you need to grasp whenever you are working with number base. Questions may be coming in some other formats. Maybe they want to actually tweak the question, give you some means to actually work it out, but this is the baseline, and the examples we are going to be looking at now is going to help us get a very good grasp, so that if you get to meet this in any of the questions that we'll be confronting in the exam, it's going to be a walkover. So let's head over and solve a number of questions. And as a rule of thumb, you don't just watch these videos and believe that you are proficient and you are competent. If you are aiming for excellence, then you need to get your hands dirty. You need to lay your hands on as many questions as you can come by, and then that will enhance your proficiency and to put you on that track to excellence. So as you're going to be solving these questions, what I just want you to do is that walk along. If you are seeing the question, you can pause, attempt it by yourself, look at what you are going to get, and then see what we're also going to get, and even beyond these questions we are going to be featuring, also lay your hands on so many questions, and we believe doing that will actually give you that excellence you are looking for and make you the best that you want to be. So let's go ahead and solve a number of questions together. In this question, we have to find R if 6R7 to base 8 is 511 to base 9. And if you look at this, the best way you can go about solving this is to convert both the left hand side and the right hand side to base 10 so that you can flatten it out and see how to solve for R. So building on the foundation we've laid before, you can just express this as 6 multiplied by 8 plus R multiplied by 8 plus 7 multiplied by 8. That is your left hand side, and then you need to take incremental values of the base, which is 8, from the left hand side to the right hand side. So we increase from 0, 1 and 2. Okay, so if you have done that, you can also go to the right hand side and say 5 multiplied by 9, which is the base, plus 1 multiplied by 9 plus that other one multiplied by 9. Okay, let me just move my work area. And in the same way, you can just increment the power starting from the left hand side, 0, 1 and 2. So once we have this, we can say we want to go ahead to try and solve this. As much as possible, we are not going to be using the calculator unless we just have to. So we have 8 raised to power 2 is 64. We are going to have 6 multiplied by 64 plus 8 raised to power 1 is 8. So that will give us 8R plus any number raised to power 0 is 1. Then 1 times 7, that is 7, is equal to 9 raised to power 2 is 81. So we have 5 multiplied by 81 plus 1 times 9, that is 9, plus 9 raised to power 0 is 1. 1 times 1, this is 1. So 64 multiplied by 6, 6 times 4 is 24, remaining 2. 6 times 6 is 36, plus that 2, that will give us 38. Then plus 8R plus 7 is equal to 5 times 81 will be 405 plus 9 plus 1, that is 10. So we have 8R is nothing but 405 plus 10 is 415. Okay, minus 384 plus 7, that is going to be 391. Okay, so what we have is 8R is nothing but 415 and 391. So we have 15 here, and then 9 with 391 we add up to 400. So it will just be 15 plus that 9, which will be 24. And if we divide both sides by 8, we have R to be 24 over 8, and that is nothing but 3. So that means the value of R that is in this place is nothing but 3, and the number would have just been 637 to base 8 is the same as 511 to base 9. So looking at the options, we are seeing 3 here. That is the correct solution to this question. Okay, this is a similar question now, and I think this should be a workaround for you. You can just go ahead and just solve exactly like the same way that we did that, and I think you should be able to get this out. I will not do this. Lay your hands on this and let's see what to come up with. Okay, looking at this question, we have to convert 112 in base 6 to a number in base 3, and like I explained, it will be best that we first convert this to a number in base 10, and then we take that number to base 3. So first we have to convert to base 10, convert to base 10, and to do that we just say we are taking this number 112 in base 6. To convert it to base 10, we take each of those digits, multiply by the power. Okay, so 1 again, and then we have 2 multiply by 6, and then we take the incremental value of the power of that base, 0, 1, 2, starting from the left hand side. And if we are to expand this, this is going to give us 6 raised to power 2 is 36. 36 times 1, that is still 36, plus 6 raised to power 1 is 6. 6 times 1 is 6, plus 6 raised to power 0 is 1. 1 times 2, that is 2. So this is going to give us 36 plus 6, that is 42. 42 plus 2, that is 44 in base 10. But we don't need to write in base 10. We just know that 44 is in base 10. Then we want to now convert to base 3. So we convert 44 to base 3. And like I explained the other time, for us to do that, that means we need to divide by 3. We take 44 as a number, and then we want to write long division, and we divide by 3. 3 in 4 is 1, remaining 1. We'll bring that one here. 3 in 14, that will be 4. 3 times 4 is 12. So 14 minus 12 will give us 2 as a remainder. 3 again in 14. 3 in 14 will be 4. 3 times 4 is 12. 14 minus 12, that will be 2. So we have 2 as a remainder. 3 in 4, that will be 1. And 1 will also be the remainder. And then 3, if you want to divide 1 with 3, you can say it's not giving us a whole number, but then that 1 will be the remainder. And again, we take this number up like this, and then we express out that value, which will be 1, 1 from the base, 1, 1, 2, 2, 1, 1, 2, 2 in base 3. So this is what we need to look out for in the option, and we can see option D is corresponding to that, and our answer is done and dusted. Here we are to convert 27 in base 10 to another number in base 3. It is exactly just like the question we just looked at, but now they have already converted this question to base 10 for us. All we just need to do is to divide by 3. So let me just give that a shot to say we want to take this number 27 and we want to divide by 3, which is the base we want to take it to in long division. So 3 in 27, that is 9, and there is no remainder because 3 times 9 is 27. So again, 3 in 9, 9 divided by 3, that is 3, and again there is no remainder. Okay, so now I have 3 divided by 3, that is 1, and again there is no remainder. You can see our answer is coming out, it's looking like D. Then 3, if I'm using that to divide 1, I'm not going to have any whole number, but the remainder will be 1. So if I want to take the solution to this, I'm taking it upward from the base, and that's going to be 1, 0, 0, 0 in base 3, which is featured as option D in this particular question. Okay, this is quite interesting now. I have to find the value of the addition of these two numbers, but they are in base 2. So now you may want to think of taking them to base 10 and then adding them and converting back to base 2, but that will not be quite optimal because time may not be of the essence when you are writing the exam. Then we can try and go ahead to add this in base 2. Let's just write the numbers out. We have 1, 1, 0, 1, 1, 1, and then 0, 0, 1, 0, 1, and both of them are in base 2. Okay, so this is quite interesting now. Let's see how we can add them. Remember, we said that base 10 is the default with which we actually add. And if you're adding, say, a number like 8, if you're adding 8 plus 3, because 10 is a rounding up figure, we could have said 8, then 9, 10, that 10, we are rounding up with it. Then we have 1, as if we are starting that counting again. So we can say it's actually 10 plus 1. So we say it is nothing but 11. That principle we can also apply here. So if any number is getting to 2, we can take it that we are writing that as 1, 0, as if we have reached the maximum of that number base in which we are working. And then we can continue writing 1 and recounting from the base again. So that's what we're going to do here. 1 plus 0, that is quite easy. You don't have any issue, it is 1. 1 plus 0 again, this is 1. Okay, now 1 plus 1, that is 2. But we don't get to 2. We just actually say that is going to be 1, 0, 10. So we have the 0, and we take the remaining 1 down to this particular place. Okay, and there, interestingly, we have 0 and 0. If we add that 1 to it, it will be 1. Okay, and then again, that same principle applies here. 1 plus 1, already we are reaching the maximum base. So we have 1, 0, we have the 0, and then this remaining 1, we can bring it here. And it's just be like here again, it is going to be 1 plus 1, that is reaching the maximum. So we have 0, and we write that one stand alone. So this is going to be the value of what we're going to get expressed in base 2. And if you look at the options, we are seeing 110, 110, okay, 100, 100, and 1. So option C here is looking like the correct option. It is 100, 10, 11. So that is the solution in this particular case. What you need to note is just to know that if you're adding and they are getting to that base that you're actually working with, you need to round up and start your counting from the least number all over again. And with that, you'll be able to get that and solve your question up. Okay, this is quite an interesting question now. We're asked to find the value of 101, 100, 011 in base 2. We have to find it in base 8. And to make it interesting, we are given this table. And I think the temptation for students is that you just want to look at parallel conversions and maybe try and break this down and think that, okay, if I can actually look at 011, what is it in base 2? 011 is this. And what is it in base 8? This is base 8. And you just solve it like that. Well, interestingly, that will be a very gross mistake, because you first need to be consistent with the way you've been solving, and then you can go ahead to be sure that you're on the right path. In this particular case, the rule of thumb is to first convert to base 10 and then from base 10 convert to base 8, and that's exactly what we're going to be doing. But now this is quite interesting because I'm having zeros, and zeros are not of interest to me. I know I'm going to be multiplying by powers of 2, starting from the right hand digit and then increment down to the left hand side. So if I want to do that, I know I'm going to say this is 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 3, 4, 5, 6, 7, and 8. Okay, but then this is where it's interesting. All those zeros, I don't need these values, so I'm not going to be bothered with that. So this is a quick way for you to just try and solve this and get your answer as fast as possible. You have 1 multiplied by 2 raised to power 8. Okay, then the next one you have 1 multiplied by 2 raised to power 6, because the 2 multiplying 0 will eventually give you 0, so you don't need to bother yourself with 0 multiplied by 2 raised to power 7. So that can be jumped so that you can effectively get your solutions fast and good. So we have 1 multiplied by 2 raised to power 5. Okay, then again plus, these are zeros, we don't need them. We have 1 multiplied by 2 raised to power 1, and then lastly 1 multiplied by 2 raised to power 0. Okay, so 2 raised to power 8, 2 raised to power 5 is 32, 6 is 64, 7 is 128. This will be 256. 256 plus 2 raised to power 6 is 64, 2 raised to power 5 32, 2 raised to power 1 is 2, then 2 raised to power 0 is 1, 1 times 1, that is 1. This is going to give us 64 and 32, 96, 97, 98, 99. So if I take 1 from here, I add it to 99 is 100. I have 255 plus 100. So this is going to give me 355 in base 10. Nobody asks us to look for that in base 10. So we can take 355 in base 10 and divide by 8 so that we can find the corresponding answer in base 8. 8 in 35, that will be 4. 8 times 4 is 32. So we have 3 remaining. 8 in 35 again is 4. We have 3 as a remainder. 8 in 40, that will be 5. 8 times 5 is 40, so we have 4 remaining. 8 in 5, you can say it's not giving us a whole number, but we have 5 as the remainder. So if we take this up, you can see our value is from the number at the base, that's going to give 5, 4, 3 in base 8. And if you look at the option, that is option A, that is going to give us the answer. So this is the right approach, and you will do it to be consistent with it, and your answer will be out fine and good. All right. Okay, here in this question, we have x, which is in base 10, is 23 in base 5. We have to find x. Students, you should be able to do this by yourself without me having to solve it. If I just want to solve, I can say converting 23 in base 5 to 10, that will be 2 times 5, which is 10 plus 3, and that will be 10 plus 3, 13. D is the answer. Work that out, and if you've been following our questions and solutions all along, that should not be a problem. But your answer in this particular case is nothing but 13, which is option D. So get your hands dirty and let's see that you're on top of that also. Okay, this is quite interesting now. We have to find the base in which this addition was performed, and we are having all these numbers. We want to look for what number base are we carrying out this addition operation. So like I was explaining, in the rule of thumb is that once you get to the base that you are working with, you render that as 0, and then you count, you loop your counting starting from the least digit, which is 1 again. So in this particular case, we have, let me just take the last set of digits in which we have 2, 3, and 1, and we want to justify what they got here as being 1. Okay, so let's look at that. We are saying 2 plus 3 is 5, 5 plus 1 is 6, but instead of writing 6, they wrote 1. But we know that, okay, this is 6. That means that you have rounded up the number base, and then you have 1 as the incremental value to it. That means that that number base is nothing but 5, because once you get to 5 and you render 5 as 0, then 6 will be the other interesting figure. So that means I'm inherently saying that it is base 5, but then from base 5 we've gotten to base 5, but we have taken 1 and we are going to add it to the next set of digits so that we have only 1 remaining here. So if we want to take the next set of digits, we have 1, 1, and 3, 1, 1, and 3, and this is quite consistent. 1 plus 1 is 2, 2 plus 3 is 5, okay? Then plus this 1, it is 6. But instead of writing 6, we're again going to write 1, saying that we're also borrowing another 1 to be used in the next set of digits. And those set of digits, now we have 3, we have 0, and we have 1. Okay, I think this will be sufficient proof for us to know that it's base 5. 3 plus 0 plus 1 is 4. Then plus 1, it is 5. But instead of writing 5, look at what they wrote. They wrote 0. So they are taking 1 and carrying it over to the next set of digits, such that here they can have 2, 1, and 2. 2 plus 1 is 3, plus 2 is 5. And then plus that 1, it is 6. And of course, we are saying that we have rounded up already. So that 6, we write it as 1, and we have that 1 remaining carried over. So this is nothing but base 5, and the correct option will be, in this case, option C. All right. Okay, just like the question we just treated, again we are being asked the base in which this operation is being performed. And look at this. In short, the very first set of digits to add up is giving us the answer already. So this should be a workaround for you. 1 plus 1 is supposed to be 2, but we are rounding up to 0. That means this is nothing but base 2. Base 2 is the operation here, and the correct option will be option B. So student, verify just like we verified the previous question, and you see that you arrive at base 2 as your solution. Okay, this is quite an interesting question. We have to evaluate 101 in base 2. We are asked to evaluate it to the power of 3. Okay, you can actually choose to do it 2 ways. Is either you convert to base 10 raised to the power of 3, convert back to base 2, or you actually multiply directly in base 2. Okay, let me just do the 2. If you want to do that, first 101 in base 2, if you want to convert to base 10, that will be 1 multiplied by 2 plus 0 multiplied by 2 plus 1 multiplied by 2. We have this 0, 1, 2 as incremental power. So this is 2 raised to power 2 is 4 times 1, which is 4, plus any number multiplying 0 is 0, plus 2 raised to power 0 is 1. So this is nothing but 5. So this will be 5 to the power of 3. So we have 5 to the power of 3. So this is 5 to the power of 3. And that is nothing but 125. Okay. But then if we want to convert 125 back to base 2, we can just do well to do our long division. 2 dividing 125. 2 in 12 is 6. 2 in 5, that is 2. We have 1 remaining. 2 in 62, this will be 31. We have 0 remaining. Okay. 2 in 31, that will be 15. Because it's an odd number, it will remain 1. 2 in 15, that will be 7, is also odd number, remaining 1. 2 in 7, that's 3, an odd number, remaining 1, not 3. 2 in 3, that is 1, remaining 1, and 2 in 1, you can say we have no whole number, and then 1 is remaining. So this set of numbers, starting from the base, we have as 1, 2, 3, 4, 5. 1 in 5 places. So 1 in 5 places, 1, 2, 3, 4, 5, then 0, 1 in base 2. This is a solution, and I think we have that in option C. 1, 2, 3, 4, 5. This is the correct solution. So first I will just do 1, 0, 1 multiplied by 1, 0, 1. So this will be 1, 0, 1 raised to power 2. So let's just be consistent. 1 times any number will be that number. 0 times any number will be 0. 1 times any number will be that number. So this is the rule of multiplication. Since it is long multiplication, you can actually follow that the number I'm multiplying is the base at which those set of solutions are going to start. So here, if you are to add this, we have 1, 0. 1 plus 1 is 2, but since it is in base 2, we have 0 and carry 1 over. So here we have 1 and 1. So this is 1, 1, 0, 0, 1 in base 2. That is raised to power 2. But we have to solve to the power of 3. So we need to multiply by 1, 0, 1 base 2 again. So we have 1, 1, 0, 0, 1 multiplied by 1, 0, 1. So this we can multiply to raise it to the power of 3, and we have this as 1, 0, 0, 1, 1, then 0, 0, 0, 0, 0, then here 1, 0, 0, 1, 1. Okay, so if we want to find this, we just need to add all of this now, and that addition would have given us 1, 0, 1 base 2 to the power of 3. So we have 1, we have 0, we have 1, 1, 1, 1, and 1. And look at this. This is exactly the same as what we have here. So, okay, leave your comments in the comment section and let me know which one you prefer, whether it is method of first converting to base 10 and then solving like this, or you just want to do your multiplication directly. I want to get your vibe to see what you really prefer. But whichever one is convenient for you, whichever one you have mastered, you have practiced, I think you'll be good to go. If you are quite versatile, you can do multiplication straight. If not, go through your normal conversion and then raise to the power of 3 and convert back. You will arrive at the same answer as option C. Alright. Alright, we are going to round up with this question, and this is quite interesting, and it's interesting if you have waited to actually see this. You're going to see that this is something that you need to take note of so that you don't even make mistake in trying to solve it. So we have this question and we're asked to find its equivalent in base 10. That means they want us to convert this number in base 2 to base 10. And as our rule of thumb, we are going to be multiplying with 2 and then increasing the powers and quote. But let me show you something. Now, I'm seeing that I have 1, 0, 1, 1, 0, and 0, 1, 1. So first and foremost, if I want to do incremental value, you know that it is actually these numbers that I've been talking about. We've not been talking about decimal place. We've not. So we are saying that for these particular ones, you are going to multiply with the base and increase the power from 0, 1, 2, 3, and 4. But look at what we are doing here. This is showing that you are actually reducing. If you are moving from the left hand side, this is showing that you are actually reducing the power from the highest number, and you are going and reducing by a sequential order to another. That means if you want to continue, this will be, you get it? Yes. I think your guess is as good as mine. Minus 1, minus 2, and minus 3. So even if you have not seen this type of question before, I think you should be able to actually come to this conclusion that this is before the decimal place and this is after the decimal place. Okay, this is quite interesting. And then again, like I said, those numbers that are featuring 0, I don't need to reflect them so that I don't waste my time and energy. So I'm going to have, I have 1 multiplied by 2 raised to power 4 plus 1 multiplied by 2 raised to power 2 here, okay, plus 1 multiplied by 2 raised to power 1 plus I don't need this 0, so I can just take note that these are the ones before the decimal place, okay, plus now the ones after the decimal place. I can say 0, I don't need that. I have 1 multiplied by 2 raised to power minus 2 plus this other one multiplied by 2 raised to power minus 3. Okay, so students, if you can actually get to grasp this, you'll be able to actually tackle any question that is coming onto you in this regard. So 2 raised to power 4 is 16. 16 times 1, that is 16, plus 2 raised to power 2 is 4. 4 times 1 is 4. 2 raised to power 1 is 2. 2 times 1, that is 2. That is before the decimal place. Plus, now, 2 raised to power minus 2 is just like your law of indices, in which you have a raised to power minus n is nothing but 1 over a raised to power n. So, if you want to apply that here, we are going to have, this will be 1 over 2 raised to power 2, okay, plus, in the second case, 1 over 2 raised to power 3. All right, so if you want to solve this, 16 and 4 is 20 and 2, that will be 22, plus 1 over 4 plus 1 over 8. So this is nothing but 22 plus 1 over 4 is 0.25. 1 over 8 is half of that, that's 0.125. Okay, and then if you look at this, this will be good. This will be nothing but 22.375. Okay, and I love the set of options that they are giving here. Already they made it that only one option is carrying 22. So even if you are coming at a loss on the right hand side, then you can be intuitive enough to say, okay, 22 is looking like it. Of course, any number after decimal place is not going to be up to 1. It's quite low, so I can be consistent with that. But actually, if you want to know the way to go about it, this is how you go about it. And with that, I want to believe that you'll be set on your way to excellence. That is all we're going to be having today. But like I said previously, it is as you practice this that I actually get to be proficient in it. I hope you lay your hands on those set of questions that I was leaving for you to actually attempt. That will really enhance your proficiency. And even if you want to take it a notch higher, go and get your exam packs, go and get your textbooks, flip through all the questions you can pick on number basis, and then use that as a leverage to build your proficiency. Trying 50-100 questions is going to actually be of great help, so that whatever question is coming on this, you know you have it on your fingertips and you are good to go. Wow, it's DaveTuts Academy. Don't forget to subscribe, don't forget to like our video, and until next time, God bless you.